Welcome, David Wiss here, registered dietitian nutritionist with Nutrition and Recovery. Today we're going to talk about the very interesting relationship between alcohol and hemoglobin A1c. A1c was discovered in the 60s and has been used since 2010 to screen as well as diagnose both prediabetes and diabetes. Now, in order to truly understand hemoglobin A1c, one must understand hemoglobin, which is a part of red blood, and A1c, which is a measure of glucose exposure to that red blood over a 2 to 3 month period. Now, understanding the glucose system in itself is very complicated. It involves multiple organ systems, the pancreas, hormones like insulin, adipose tissue, the liver, and it's going to be different from person to person. It's also important to know that there's a common misconception that alcohol turns into sugar, and it's physiologically impossible. Ethanol is a 2-carbon molecule, also known as alcohol, which enters the Krebs cycle by way of acetaldehyde and acetate, which is similar to the end product metabolism for glucose, but they are not the same molecule. Alcoholic beverages can have a lot of sugar in them, but ethanol itself does not turn into glucose. We also know that diabetes is exploding in the U.S. Rising prevalence in the last several decades. You can see here the trend increasingly positive over the years. Latest estimates are somewhere around 14% prevalence of diabetes in the U.S. Now, interestingly, there are reports that alcohol consumption actually lowers the risk of type 2 diabetes. This is a classic U-shaped or J-shaped curve, which means that as people start to drink moderately, there is a decreased risk, but once they start drinking heavily, the risk for type 2 diabetes goes up. So one might start to wonder, what is it about alcohol that could decrease the risk of diabetes? Is it the alcohol itself, or is it people who drink? Now, this meta-analysis, which pooled a lot of data together, showed that the relative risk decrease of diabetes related to alcohol switched at around 6 drinks. So in other words, under 6 drinks per day was protective, and once you got over 6 drinks, it was actually linked to increased diabetes. When stratifying for males and females, it was shown that this effect of alcohol decreasing risk for diabetes was more pronounced in females than it is in males. And again, it points to this question: is it the way alcohol is metabolized by females, or is it the socio-cultural gender effects of differences between men and women? I do believe that when looking at biological relationships, it's important to always consider social factors. This particular study looked at both gender, which is socio-cultural, behavioral, environmental, and sex, which is physiological, which focuses on hormonal differences, genetic differences, etc. It's also important to acknowledge that there's differences across ethnicities in hemoglobin A1c, which might be linked to differences in hemoglobin. So think about it for a second. If different ethnic groups have different levels of hemoglobin, they're likely to have different levels of hemoglobin A1c. And if we use the same set point to diagnose all cases of diabetes across all ethnicities, it might actually be contributing to disparities in our health outcomes. So in this particular study, it was shown that older males, non-Hispanic blacks, and those with higher BMI as well as lower education had higher A1c levels after controlling for other covariates. This particular study did look at alcohol as it relates to A1c. Now, keep in mind that most studies don't, so this is a kind of novel idea. You could see here the beta is negative 0.73, which means that increasing alcohol decreases A1c by a statistically significant amount. And these are the things that have started to catch my attention, because I'm asking, what is it about alcohol that lowers A1c? Is it the alcohol itself, or is it the social factors associated with alcohol consumption? This study looked at the genetic factors, the actual genetic variants that are associated with alcohol and glucose. and did find that it was different for men and women. So I think it's important to always consider social as well as biological factors whenever building a model or looking at a relationship, to look at all of it. I call it the biopsychosocial model of health. Now, this relationship doesn't make sense without considering insulin. Insulin is the hormone that regulates blood sugar, and the big question that has not been answered is, how does alcohol affect insulin? Now, it's also important to remember that alcohol affects the quality and the patterns of one's diet. So you can see here that as alcohol goes up, percentage of calories from carbohydrates goes down. So these are things that are obviously going to affect both insulin status as well as glucose status. And this was different for males and females. I love this particular study because it brought together different biological and social factors. So this is a very complicated model that involves moderation and mediation, that looks at A1C outcomes and definitely the link from alcohol. Now, one might think that if alcohol is protective of type 2 diabetes, that it would make sense for people at risk for diabetes to drink alcohol. But I want to caution people with this consideration. Alcohol can worsen diabetes-related complications by affecting fat metabolism, nerve damage, and eye disease. A couple of biological facts to start bringing this all home. Alcohol affects the way glucose is created in the liver, the way that it's broken down in glycogen storage. Alcohol lowers blood sugar by improving insulin sensitivity in the short run. There's definitely some questions about what it does in the long run. And also, red blood cell turnover does vary across different gender and ethnic groups. So, in conclusion, glycemic status appears to be worsening in the US. Having universal cutoffs for hemoglobin A1c may not be applicable to all groups. Racial and ethnic differences should be considered. Alcohol consumption patterns should be considered. Heavy drinking can lead to a misleading clinical conclusion about glycemic status. So, considering the social determinants of HbA1c should be further investigated using the fundamental causes theory framework, as well as looking at some of the biological mechanisms. I've proposed this model to consider the outcome of A1c, which looks at alcohol mediated by insulin, social factors like SES, and behavioral factors like exercise, smoking, nutrition, and then some of the biological factors like lipid status, BMI, etc. Do you have thoughts on this topic? Please share them with us. We'd love to hear from you. My name is David Wiss, signing off for now.